Just we will start off like last time. Do you remember we saw like the linear regression and all those stuff? If you will try to remember,
Yeah,
and I shared you the Google
yeah.
Classroom notebook. I hope you have tried it. And is there something that you want to share from what you did, or anything that you want
Um,
to share your screen and show? Today we'll be just looking at some regularization regularization techniques and some code for that, and we'll try to understand few more concepts related to linear regression, the mathematical part, and some coding behind and we'll write some code around it. If you have something, you can share your screen and or you can just tell.
I've not really got much because I've not really done much, unless I want to share from the loan approval data sets. If that's what you want,
Hmm.
I can get out for the loan approval data sets. Is that the one you want me to share?
Yeah, you can share your screen and just give a quick overview, like what you did or what are you currently doing with your learning.
I've not been doing anything because the only thing I've just done is I've just kind of taken a note of the last few classes we've done where you've taught me about model evaluation, looking at the loss function
Hmm.
and techniques we could use at, get to the loss functions like the MSE, MAE, and
Hmm.
we've looked like regularization techniques like Lasso regression, regression. I understand that regularization helps with overfitting, and
So did you
that's
write
Lasso.
the code? Did you try the code for ridge regression, lasso regression, and try to understand
No,
how it works?
no, I didn't try the code. I've not gone into the code at all.
Okay, okay, no problem. We will do it. And have you looked at this bias variance? Oh, you know the overfitting, right? Overfitting and underfitting.
Yeah,
You know, like what does
yeah,
underfitting mean? Like actually, like what?
yeah, yeah, yeah. I know it.
Can you try to tell me like what overfitting and underfitting is?
So overfitting is where our model does well on training data sets and begins to have very low score or on test data sets or on seed data sets because it was just memorizing. It wasn't really learning the patterns. That's overfitting. Then we've got underfitting where our model is just more on it's not doing well on the training set and it's doing very badly on the test set also. Yeah, so
Right,
that's underfitting and
right, right. So basically, you just have suppose one feature and your model is just biased with that one feature, right? So that is
yeah,
underfitting, right? And when your variance is and when you have the variance in your error, so basically your model is too complex. That's your underfitting. Like you have multiple different features and each have very
yeah,
high coefficients. So that is what you try to do in your regularization, right? You try to bring those coefficient down. Like you will try to reduce those coefficients so your model is
yeah,
easier to understand and it has less features, right? And that's the main difference in your ridge regression and lasso regression. That your lasso regression uh, makes your entire feature takes it entire feature into zero, right?
yeah,
But ridge regression, sorry, ridge regularization or regression basically will reduce your coefficient. It will not uh, take your features to zero. So basically, they also have a hyperparameter that you can choose according to your data set, basically to tune how much feature or how the feature you want, which how many features do you want to get zero, right? Or how strict you want these techniques to be, right? Basically, how simpler do you want your model to be? If you will set that parameter, we will look into the code and you will try to get to it understand better. Basically, that's how you can play around with your this these techniques and see which works best for your data set, right?
Okay.
And also like I will suggest you one thing to try it on yourself. If you get any issue, you can tell me, because we are already running late on the syllabus or on the course. So you can try cross validation on your own, because this is also a very um important
So
uh
which one do you want me to try? Cross validation.
yeah, cross validation you have to try. Like basically
Okay.
some libraries are there in sklearn. You have cross val score. In sklearn model selection you will find cross val score. It also has some parameters, so you have to try that. So just take it as a note for the next session. Maybe you can bring a collab notebook and you can try, or you can show me like how your cross validation code is working there, right? So that you also have something that you learn. So you can just take a note of it, and probably in the next session, you can show, right? I will expect in the next session you to try this cross validation and understand a concept like k-fold cross validation, and right, and understand
Yeah.
bias variance, right? There
Yeah.
are bias and variance in the cross validation.
Yeah,
And
I'll try it on my data set, and I think this data set I need to rebuild it with the kind of things I've learned now. I need to redo a lot of things. I think from the training. Yeah, yeah. I'm just gonna you
feature
open the folder and just
feature selection, I think you have gone through it already, right? So this is like
yeah.
Lasso regression is also one of technique of feature selection. So there is feature
Okay.
scaling. For feature scaling, there is another library in sklearn that you can refer to, right? And there's standard C
Yeah.
all that I think we have already discussed, right?
Yeah.
So this also you can try. Apart from this, there are only few concepts that are left, and you can try it on your own as you find them on your projects. This will be enough for the fundamental. Now, the more the advanced after this, some advanced ML model will be left that we will try to do in the further session, right? Like XGBoost or some good ML models, right? And
Yeah.
like how they work, right? So basically, today, like most of your fundamentals will be clear, right? So we have
Yeah.
talked all over those things. I will just share the screen and give you a quick. I think I can do the,
So if you could do me a favor,
yeah.
so the ones the cross validation, bias and variance, all of those things you want me to go learn on my own. If you could just give me a list, maybe after this class, so I can just, be able to make sure I'm taking everything you want me to go learn on my own off. So I'll just go be doing the learnings on the background.
Yes, it's just cross validation only. So just do that only. So you can just note it right now. That will be fine.
Okay, cross validation.
Cross validation on your collab. If you find any topic related to it, that is also fine.
What is cross validation? So I'm just gonna check Medium.
Mm. You are able to see my screen, right?
Yeah, yeah, of course.
Yes. So here you can see like we have gone through all those things. EDI data
Yeah,
processing and all those things are covered. Now, mostly like let's try to cover this quick, and we will move into this um, supervised learning and unsupervised learning, and some of these um, ensemble methods, XGBoost, random forest, and your some of your natural language processing techniques, right? If you get
yeah,
some time, and
yeah.
then if you're interested, we can do some LLM and LLM stuff,
I'm
right?
interested. I'm interested. Very, very interested.
Yes. So cool. So once we are done with this, we will jump into that section and we'll start off there with that, right? So
Yeah,
yesterday we were here, not yesterday, last time. So here, what we saw was how your intercept and coefficient were trained using your linear regression, right? So once you do
yeah,
dot fit here with your train and Y train, feature and your label, it will try to calculate a coefficient and intercept, right? This
Yeah.
m value and c value. And if you don't have any noise here in your training data set, in this training data set, it will exactly find those coefficient and intercept, right? Basically, what we does was we give this value, we trained a synthetic data using this equation. That means we were using this equation and the exact data set we were using, right? And that data set we gave it to the model, and the model told us how the equation looked like, right?
Yeah. Yeah.
So it was able to exactly tell like what is the value of m, what is the value of c, basically 2.5 and 5. So this was the equation, right? 2.5
Yeah.
into m, this is the m
That's
into
five.
x plus 5, right? So this was some noise, right?
Yeah.
If we add some noise, this there will be some this this value will be not that accurate with the this equation, because this noise is random, right? So this random noise
Yeah.
is added to your data set, and this will cause your difference in your slope and intercept. Okay, fine. So it is connecting, the whole collab is connecting, and once this is connected, we will be able to execute this, import all the libraries, and we'll start off. So here we are importing it. Here we are generating the x values. Here we are finding the y values from that x, right? So here this x is generating random values from 0 to 10, 100 values, right? 100 values from 0 to 10. So we will see 1, 2, 3, 4, right? And now we are finding the y, the labels. The labels is generated from this equation, the actual, right?
Yeah.
Now from this, 20 are taken for training and 20 are taken for test. So training values are this. This will be 80, right? Okay, cool. So I think you got this point till here, right? Now you, on that 80, it will be trained, the model will be trained, and on basis of that, it will try to find the value of your slope and coefficient, right? So now what we are trying to do is artist score, right? So what we can do is we can do a plot, maybe if we can try get this np.xt. We have not imported the module. Let me check. Mhm. So basically what we are trying to do is here is we are trying to plot these variables, and I think probably I have given the variable name wrong. Let me see once, verify it. Uh, just a minute.
Where did you get SQ test from? You didn't define it.
Yeah, yeah, right, right. Just let me get the written code. I have a pre-written code, so I'm just trying to get it.
Okay, that's fine.
Yeah. So that variable name is different here.
Do you know about do you know about backend? Node.js, Express Server, Redis. Do you know about those kind of things?
Redis, red. So that all comes in the software development part, right? That is not
Yeah.
what is what we have prepared for this thing.
No, no,
Uh,
no, no. I'm just asking, like, do you have an idea of those kind of things?
yes, like they are mostly used. So see, Celery is used for your parallel jobs, right? Like if you are running multiple processes on your backend. So Celery is
Okay.
Redis is used for that. Celery is used for your messaging, right? messaging, like suppose you, Redis is used for your messaging, right?
Yeah.
Basically, if you are doing any, suppose, any task that is running on your backend, like logging or something, that is used there. I'm not able to
Yeah.
find the code, but just give me a minute.
Yeah, that's fine. Take your time.
Okay, fine. I will take a stick from here. This we have regression here. Then we have polynomial regression. So in your polynomial regression, basically you get of multiple degrees, right? So in linear regression, you just had 1 degree, right? Here, this y is equals to mx. So you had just one. Here, if you will see here, it is 1 degree. So if you have like this square, a to x square, right? A n x n, right? So it is multiple degree, right? That means
So what does that degree mean in real terms? What would degree mean in a real
basically you will have
live data
curve,
set?
right? Suppose you are seeing here the linear line, right? Like a one straight line. But suppose if you have a multiple degree, so now your curve, it will have a curve, kind of, right? Where your data is plotted. And now in that curve, we have to find out what will be the predicted value. Are you getting a point?
Yeah, so how does that, when do we, what kind of real life data set? I'm trying to understand it in the real life that, okay, if you're working on this type of data set, then you have to use linear regression. If you're working on this type of data sets, you have to use maybe polynomial. I understand everything, polynomial, because it's going to pick
Right.
up
Got
different
you.
points, so it's going to be
Yeah.
curved.
See,
Linear is a straight line,
right.
but
So can you tell me, like, you got the data set, what is the first step that you do?
if I've got the data set, yeah, I do EDA, do data
ETA, right?
processing.
So
Yeah,
you will plot your data and you will see the how your data looks like.
yeah.
So if your data is in a kind of a straight line, that tells you that it is a linear regression or a linear model will fit that. If it has a multiple curves, you will find that this is now polynomial regression can be a better approach for this. So basically, that's why I told you at the first, like exploratory data analysis is the first part, and it is the 70% of your task. Like you will
But
see missing values,
how,
multiple.
how do I plot the data to linear regression in EDA?
Basically, you don't have to plot specifically for linear regression. You will just plot your
Yeah.
data and try to look at it. You will be able to figure out if it is a straight, the data points are plotted in a straight line.
Oh, okay, okay, okay. So I'm trying to understand now. Oh. So when you're doing the EDA, I've seen maybe I'm just doing some Instagram or I've kind of fit the data or something like that, and I'm just plotting because obviously I will do some pie charts just to understand each features or the target feature. So
Hmm.
if I feel like the plotting looks a bit straight, like it's going to fit a straight line, then obviously linear regression. But there are some that when I plot, it
Right.
has maybe
Right. So if I is like
too
this
many
curves, yes. So
outliers.
hmm, hmm, hmm.
Yeah, something like that. So that means it's going to be polynomial regression. So I don't have to
Right. If it has, see,
oh,
look, if you are working on clusters, right? If you are seeing like multiple different clusters are formed, right? If you are
yeah,
working on a classification problem, right? So you will see such kind
yeah,
of plots, like this kind of graph.
yeah. So
And
it's
now here you will
polynomial
understand
regression.
that this is a one class, this is another class, this is another class, and then you will try
Yeah.
to fit in classification problem, and it will try to find the distance from each point, and it will kind of set a boundary, and with all the points within that boundary will be a one uh, class, right?
Yeah.
So the first step again is the EDA, exploitative data analysis.
Yeah. Yeah.
That is
Okay.
how you will
Okay. Yeah,
identify
I'm
which model
understanding.
is to perform and which technique is to be performed.
Yeah.
All right. So once you do that, so in this polynomial regression, like here again, we are trying to do that. Now here, what we are trying to do is, you will see like for y polynomial, right? Here, what
Yeah.
we are doing is, here we are doing taking a polynomial expression. Basically, this is
Okay.
the polynomial expression, right? Y is equals to, I was telling you, right? Y is equals to mx plus c. That's for one variable. Now, if you have two features, it will be y is equals to m1 x1 plus m2 x2 plus c, right?
Yeah.
So here we have multiple feature. This is c. This is m1 x1, m2 x2, right? However, this x is same. This is the, it is squared value, right?
Yeah.
Because it is polynomial feature. Now here the feature is one, but again the equation is polynomial. That means it is not just a straight line; it is a curve. However, the feature is one. Again, this feature can be a multiple feature, right?
Yeah.
That means this can be x, this can be x2 square, right?
Yeah.
But to keep it just as simple, here it is just one feature, right? So that means
Yeah.
here we have just one feature. This x poly is one feature. That means, let me just delete this, copy it in a new page. And if I run this, so you will see x data set is generated, right? NP,
Yeah.
yes. So here if you will see, this np dot linspace will generate 100 data points ranging from 0 to 10, right?
Yeah.
So if I plot this x underscore poly, now these many features are generated, right? This is one feature. For each observation, we have one feature, right? This is value of x, right? X, right?
Yeah.
Now we will fit in this equation. Yes, x poly, sorry, y poly. Now in this y poly, you will find y. Now see in this x, this value will go inside this, right? And this gets squared. This is the 3, and this gets squared. And here this x value will come, right? And this is 10,
Yeah.
this value is coming 8, right? So we are multiplying some value with this, right? And this is how this equation is formed, and this y variable is created. So if you form this value, right? If you give pass in this value or this value in this function, it will give you this value, right? So this is
Yeah.
statically generated. Now again, here you are doing a train test split with this data set, this synthetically generated data set, x poly and y poly, train size 220. It will generate 80-20 split, a random size, so that it is equal, right? Now here you are using polynomial features. This is a function name. This function is coming from a library from the sklearn processing. Okay. So if you will explore sklearn, you will find this library that is for your polynomial features, and it will help you to fit the variables. Right here we are fitting the train feature, right? Transformed. Here you are doing transformation, polynomial transformation, right? Because this was a degree 2 polynomial. Here you have specified this here. That means a one curve, right? If it is a multiple curves, then this degree will increase. Here you are using the linear regression, right? And here we are doing the same thing, dot fit. In dot fit, we are passing x and y. It is calculating now the coefficients, dot fit, coefficient and intercept. And predict, it will now test on x values and it will predict the y values. And now the y are stored in this variable. And here now y values are compared with the test value. This is the actual value. This is the predicted value, right? Now we are finding the R2 score, right? And this is the root mean squared error. So it will give you the error between actual value and the predicted value. What is the difference in the actual and predicted? So here you can see that R2 is close to 1. That means this is a good model. And RMSE is a low, right? So we just have 10 minutes. So I will quickly give you a quick understanding of Ridge and Lasso now. Hope you understood this concept, right? Are you there? Hello? Hello?
Damn, sorry, can you hear me? I've been talking and I didn't know I was on mute. I'm so
Okay,
sorry.
no problem.
So, polynomial feature, let me just say it again. Polynomial feature is just like a feature like that has some enhancements that we call when we possibly cannot use linear regression and we use it to fit on our data sets and it kinds of makes our data sets kind of scalable
Hmm.
for the model to kind of to reduce the noise for the, so what I need to understand is if you go back to how to square RMSE, what can you hear me?
Yeah, yes.
Yeah, so if you go up a bit.
Mhm.
So this outweight, so this polynomial degree, how to score an RSME, what
Hmm.
do they really mean? If we had not used polynomial degree, what would we have got? What would we have done? I'm trying to understand, like, why would we use it? What was the benefit?
So you got the understanding of the polynomial degree too, right? Is it?
Polynomial degree 2, no, I don't understand what it
So
means.
basically your polynomial degree 2 is here is the maximum value will be your square. This here. We are just doing the square of 2 maximum, right? If it is the 3, now this is the degree 3, right? This thing. Let me show you the equation.
Okay. Okay, is that the hyperparameter that we'll be tuning?
This is not the hyperparameter. This is the how your data is spread, right? Here we are generating it.
Okay.
Like this is your how many curves are there. So if it is a degree 2, it will be like just a one curve. This is how your
Okay.
degree 2 polynomial looks like. Right? Here is a square, right? To this. You are seeing to here.
Yeah. What about if it's 3? What does it look like?
If it is 3, it will look like this. It will have now these two curves. One, then two. Right? Here.
Okay, the curves. Oh, oh, can you? Oh God, I don't know where my pyros are.
Yeah, yeah.
Uh,
So basically, this tells you how complex your data is. Like if you have more degree, that means your data is spread in a more complicated manner.
yeah. So that means we'll be tuning this degree. by ourselves, depending when we're putting the formula in, depending on what our data set
Yes,
is talking
yes,
about.
yes, yes, yes. So right now we are
So it's
here we are here this data will generate in a curved fashion. This data will be in a curved fashion, right?
yeah,
In a one curve like this, right?
yeah.
In
Can
this
you
way,
plot it for us to see, or is not plottable for now?
yes.
Is the Can we plot the data sets to see the curve, or there's no need to do that?
We can do that. You can okay. You can just try it on your own as like time is also
Yeah.
less, so you can just try it as your assignment, like if you want to, or you can just show me tomorrow, right? I will share you the
All
note.
right, that's fine. So can you leave a note, since you're going to share this with me, can you leave a note to kind of
Yes.
explain this curve? The curve is the number of degree you need to edit, and so I can,
Uh,
since because I
plot
don't want to.
plot the x feature and y labels. Okay.
Yeah,
Okay. So you can do this. All right.
yeah, that's fine.
So basically, here the ridge regression code here. Basically, this here you use the ridge and you can just use it from the sklearn library, and here you this is the parameter that I was talking about, right? So basically if you change this value, and you can change the strictness of the technique, basically how strict you want your regularization to be. Like if you make it keep it a zero, it will be a normal regression, right?
Okay.
If you
Yeah.
increase it, the values will be shrinking more effectively. Like if you will increase it to higher value, like a 10 or something, it will have a high shrink. Basically, the coefficient will get reduced significantly, right? The penalty will be very high, right? If the value is high. If it is zero, that means it is just as a simple normal regression. This value of alpha, right? This is a hyperparameter that you can try and choose. If you just keep it one, it will be okay, fine for most of the cases, because this is the normal value, not too less, not too much high, right?
Okay.
And then you have to just do the regular dot fit, and here you do the dot transformed, right? And the y this thing. Okay, cool. So here you are applying this ridge in this model, right? Ridge regression dot model. Like here you have used this ridge,
Sorry.
you have this fit. So ridge, this ridge here you have imported this from a linear model, right? So this is a ridge regression. This is the same as the linear regression here, right? So here
Yeah,
you
yeah, yeah, yeah,
linear regression and dot
yeah,
fit, dot predict, right?
yeah,
The same thing,
yeah,
just here now you have the alpha, right? So
yeah,
it's same as
yeah.
linear regression, just with another parameter
So this
alpha.
ridge,
Hmm.
yeah, continue.
So if I run this, you will find that adds L2 penalty. Here I have commented this thing. And if you see the R2 score, now R2 score is 8.17. Now here if you will notice, it is much better, a little better, 8.17. It was 8.15.
8.15.
So it is
Yeah,
better, right? Again,
yeah,
RMSE is little less. That means it is good. So RMSE should be equal to 0. That means the error should be equal to 0. R2 should be equal to 1. That means we are
yeah,
going better, right? If I
yeah.
increase the alpha, let's try what I get. Now, now you see now it is going more better.
It's low.
It is improving, right?
Oh yeah, yeah. It's 7. It's
Right?
2, 3. Yeah, yeah. It's a
This
lot
is
better. Yeah,
how
that's
this
true.
is how like the hyperparameters work. Like if your accuracy is less, so then you have to look back and you have to see what are the causes of this, and
Yeah,
try to change this value and see how
yeah.
then now it's 2.5, 28. Suddenly if I do
I
50, it is again just going doing better, right? But again, like
Yeah.
it will not always do better. You have to see like when it is started getting
Oh, it has gone down.
right. So what you can do is you can plot a graph here and you can just see when it is going up and when it is starting getting down, right? You can just run a for loop or maybe or something and then you can try, right? You can just give some
Okay.
examples like to try like 10, right? Or 10, 50, 100, 150, right? And you can try on these value and just see how it is performing and accordingly choose, right? Now here similarly it is a lasso regression. Again, it will uh, even not use the coefficient. That means it will just make the uh, coefficient equals to zero, right? I think meeting will end soon. The non-coefficient are 2 cross 2 by 3. Just try to implement this and try to understand here what this code does. You will get a better
Yeah.
picture. Again, this is same. If it is a more, that means it the more the value will be exactly zero. If I increase it, now see the two are zero now. Only one is non-zero. Earlier, when it was less, then only one was zero, right? Two are non-zero. That means if you increase this alpha, more coefficients will get exactly zero, right? If I do this high like 3, now earlier 2 is 0, sorry, 1 is 0. Now I have increased this, now